Hello students, this video is about a very important phenomena exhibited by compounds known as isomerism. Now let's see what isomers are. Two or more compounds having same molecular formula but different structural formula are said to be isomers, and the phenomena is known as isomerism. The isomers, they have different physical properties. There are two types, structural isomerism and geometric isomerism. Now let's see what structural isomerism is. This type of isomerism arises due to the difference in the arrangement of atoms within the molecules. The structural isomerism can be exhibited in 5 different ways: chain isomerism, position isomerism, functional group isomerism, metamerism, and tautomerism. In the first 3 types, the definition is hidden in the names, as is elaborated in the next part of the video. Chain isomerism. This type of isomerism arises due to the difference in the nature of the carbon chain. For example, this is pentane, C5H12. The general formula of alkane is CnH2n plus 2, N5, N2n, 5 into 2, 10 plus 2, 12. So this is an alkane having single bonds, and 5 carbon means pentane. This is normal pentane, as the carbons are connected in a series from one to the other in the straight chain. But this is methyl butane, as the longest chain consists of 4 carbons, 1, 2, 3, 4, and a methyl group is attached on the second carbon. So this is methyl butane, and it is also known as isopentane, as this is an isomer of pentane, and it is also 5 carbons. And this is dimethyl propane. As you can see here, 1, 2, 3, the longest chain propane, and 2 methyl groups are attached on the middle carbon of the second carbon. So this is dimethyl propane. Students, it is also known as neopentane. And neopentane, it is the simplest alkane having a quaternary carbon. That is, a carbon attached directly to the 4 other carbons. So this is a quaternary carbon, and it is tetrahedral in symmetry, and it is known as neopentane. So these 3 are chain isomers of each other. They have the same number of carbons and hydrogens, but they have different nature of carbon chain. Now this is C3H6, this is propene. It is an alkene. This is CnH2n, that is general formula, N3 and 3 into 2, 6. So this is an alkene having a double bond, propene. And this is propene, straight chain having a double bond. But in this case, this is cyclopropane, as it is in the form of a cycle or a ring. Again, both have the same number of carbons and hydrogens, but they have different nature of carbon chain. Now the position isomerism, this type of isomerism arises due to the difference in the position of the same functional group on the carbon chain. For example, this is C3H7Cl. Here the functional group is chloro, 1 chloropropane and 2 chloropropane. The chloro group or the functional group is attached to the first carbon, and here the chloro group is attached to the second carbon. So this is 1 chloropropane and this is 2 chloropropane, and they both are the position isomers of each other. Now here this is C4H6, this is alkyne. The general formula of alkyne is CnH2n minus 2, N4, 2 and 4 into 2, 8, minus 2, 6. So this is an alkyne or butane. Now this is 1-butene and this is 2-butene. Here the triple bond is located on the first carbon, and here it is located on the second carbon. So this is 1-butene and this is 2-butene, and they both are position isomers of each other. Now the functional group isomerism, the compounds having the same molecular formula but different functional groups are said to exhibit functional group isomerism. So there is a difference of a functional group, and this type of isomerism is known as functional group isomerism. For example, this is C2H6O. Now this is alcohol or ethanol, and this is dimethyl ether. Both have the same number of carbons and hydrogen and oxygen, but they belong to very different class of compounds. This is alcohol and this is ether. They are both different functional groups. And here this is C3H6O. Again, they have the same number of carbons, hydrogens and oxygen, but one is propanone and one is propanol. This is a ketone and this is an aldehyde. So they both, again, they are very different class of compounds, but they have the same molecular formula. So they are the functional isomers of each other. One is ketone and one is aldehyde. Now let's see what metamerism is. Meta means change, and this diagram will help you to keep it in mind that meta means change. This is metamorphosis. The egg is changed into a butterfly, and you can see the change through larva and pupa. So this is metamorphosis, and meta means change. Metamerism, this means that this is that kind of isomerism in which there is an unequal distribution of carbon atoms on either side of the functional group. Or you can say that there is a changed number of carbon atoms on either side of the same functional group. Change. Meta means change. So there's a change number of carbon atoms on either side of the functional group. So in this way, you can remember that meta means change, and this is the definition of metamerism. Now let's see the examples. C4H10O, this is diethyl ether, and this is methyl and propyl ether. Now here you see that ether is the functional group, but the number of carbon chains is different in both cases. Same here, methyl and propyl ketone and diethyl ketone. Ketone, the carbonyl group, it is flanked by two alkyl groups, but here there is one carbon and three carbons here, and in this case, the carbonyl group is flanked by ethyl groups, that is two carbon here and two carbons here. So there is an unequal distribution of carbons on both sides of the functional group, and they are known as metamers of each other or metamerism. They are exhibiting metamerism. Now let's see what tautomerism is. This type of isomerism, it arises due to the shifting of a proton, that is H positive ion, from one atom to the other in the same molecule. For example, this is amino acid and this is bitter ion. Amino acid, as the name indicates, there is an amino group, that is NH2, and an acidic group, that is COOH, the carboxy group. Now, this is an amino acid and this is a bitter ion. As you can see here, bitter ion, it formerly called as dipolar, is a neutral molecule with both positive and negative electrical charges. So a zwitterion has simultaneously both ionic states, that is cationic and anionic. So this is a zwitterion. They both are tautomers of each other, and this is acetaldehyde and this is vinyl alcohol. Acetaldehyde, two carbons, one is with aldehyde and the other is with the methyl group. So this is acetaldehyde, and this is vinyl alcohol. Vinyl alcohol, students keep it in mind, it is ethanol, ene, that is CC double bond, and it has two hydrogens, and it is one hydrogen, whereas the other hydrogen, it is replaced by a hydroxyl group. This is vinyl alcohol, or this is known as ethanol. Now here you see that this is the amino acid, and here oxygen is more electronegative than hydrogen. It takes the electron and hydrogen is replaced and then transferred to the nitrogen. Nitrogen originally makes 3 bonds, but when it forms 4 bonds, it gives a lone pair to the hydrogen, and then it becomes positively charged. So now this becomes zwitterion, having both electrical charges, that is positive and negative charges, and this is a zwitterion, and these two are tautomers of each other. So this is amino acid and this is a zwitterion. And here this is acetaldehyde. What happens is that the double bond electrons, they attack hydrogen, and the hydrogen then transfers to the oxygen, and this double bond, it is then transferred here, and CC double bond is made. Then it becomes vinyl alcohol, as you can see here, CC double bond, and then the hydrogen, it is then replaced towards the oxygen. So this is vinyl alcohol and this is acetaldehyde, and there is a shifting of proton within the same molecule. So these both are tautomers of each other.